So let me share screen. Oh, and see a couple of people out there. Just be aware, you folks out there in the virtual land, that we're going to be finishing up the material for our midterm. So 2.4 and 2.5, we'll do 2.4 today, maybe a little bit of 2.5. And after that, bring in questions about anything related to what we've covered so far. And then this time next week, we'll have a review day, and then that midterm will be open until Wednesday, I believe that's what it is. So just remember that. I want to make sure you all saw that, because when I told people here and I didn't tell you. All right, so let's just look for a minute. Okay, yeah, this is right. All right, so section 2.4, it really deals with two topics. The first topic, you can almost kind of throw it out the window once you learn it, because what we're going to do in here is concentrate on this thing called synthetic division, because it's really nice and quick, and it can help us find roots real quick. But we want to look at the long division first, just so we can see where the procedure comes in. Now, some of you might remember, like if you're taking 8 and dividing it into 243, you go and then subtract 3 after 3, and that would be your remainder, that kind of thing. Well, that's the same thing that's going on with this. It's really the exact same procedure. Most people just don't think about it. Somebody have a question? Virtual question? All right. Open. All right, so let's just go through this procedure for long division. So what we do is we arrange the terms of both the dividend and the divisor. We got to have them in descending order. All right, here's where it's really important. They've got to be in descending order. And if you have missing exponents, in other words, like there's an x cubed not in your thing, you got to put in a space holder. Then you divide the first term into the dividend by the first term in the divisor. And then that's going to be the first term of your quotient up at the top. So like this, it's the exact same procedure as this. And then you multiply every term in the divisor by the first term of the quotient. And then you write it on the bottom, and then you subtract, which is exactly the same thing that happens here. Really the same procedure. And then you bring down the next term and you start your iteration over again. When you get to the end, if you've got anything left over but a 0, it's a remainder. All right, exact same thing as this. So they kind of show you this, and it's kind of gobbledygook, but it's just basically saying that the divisor times the quotient plus the remainder is equal to the original function. That's all that it means. So if we want to divide this thing, 7 minus 11x minus 3x squared plus 2x cubed, and we want to divide it by x minus 3, well, first of all, they got to be ordered. This one's not ordered, it's backwards, so we write it in order. Now there's none missing, 3, 2, 1, and 0, so we don't have to put in a space hole, but we're going to see that in a second. All right, so the way it works is, it's slightly different than this because you don't have a variable when you're doing this. But what you do is you take your x into the 2x cubed. All right, and what that's doing is, in case you forgot, or in case you never knew, because sometimes people just don't pick up on something. what we're doing is we're taking 2x cubed and we're dividing it by x. And that's 1x to the first power. All right. So that simplifies out to 2x squared when we divide. Because remember, there's two things going on here. This is a 1x to the first power, so it's going into 2 twice. And then the 1 is subtracting from the 3 to give us the square. That's a square. So that is what goes up there on that top. All right. And it goes over its common term right there. Now we multiply back, just like how you multiply here. So 2x squared times x is 2x. Forget about those signs right now. And then 2x squared times 3, or negative 3, is negative 6x. Now, what they do is they change this sign and add, which is the same thing as subtraction. This is one of those things, some teachers stress it and some teachers don't. But there's really no such thing as subtraction in mathematics. It's addition of the opposite sign. So that's why this is negative and that one's positive, right? They're just not showing you that. And then you add them up. And there's going to be a real good reason for that, because like I said, this long division, after we do it here, you can pretty much just forget about it. And we're going to go to synthetic division, which is a lot more important, a lot more useful, and it's a lot quicker. So see, when we subtract 2x cubed from 2x cubed, see, we're gone. And then when we do this, we got 3x squared left. We finished our first iteration. Then x into 3x squared goes 3x times, multiply again, 3x times x, 3x squared, 3x times negative 3 is negative 11. I'm sorry, 3x times negative 3 is positive, is negative 9, but we're subtracting, so that's why the signs have changed. This one should always go away. And then here you got negative 2x, and then bring down that 7. And then the last iteration, x into negative 2x goes negative 2 times x is negative 2x, and negative 2 times negative 3 is positive 6, but you're subtracting. So that's why they changed the sign and and. Okay? So there's your quotient. We could then, if we wanted to, multiply this by this, it'd be kind of messy, and you would come up with the original divisor. And that's what that little thing right there was saying. All it means. All right, let me take you one through real quick. And then we're going to go jump to the synthetic division, since that's what's important. All right. So let's see. First thing you'll notice that there's no missing terms. We'll see that in a minute. How to handle that. But you just basically going to put a placeholder. So to write it as division, a long division, you take the 2x minus 1, the denominator, which is the divisor, and you put it in the crook, and then you put the 4x squared minus 8x plus 6. And as I said is, once you do this once or twice, you're going to find out that the synthetic division is a lot quicker and does the same thing. And that's what we're going to concentrate on for the rest here. It's like that thing, the difference quotient that we went over a couple weeks back. It's like you see it here in algebra, and then it might more, and that's where people that are going on to the next level of math. But you find out there's a quicker way to do it over there. All right, so 2x and 4x squared. In other words, what I'm doing is this. Okay. Dividing. So 2 into 4 goes twice. Much room there, but and then x into x squared just leaves a single value of x, so 2x. Now, to finish out the iteration, we're going to multiply 2 times this. In other words, we're multiplying 2x times the 2x minus 1. All right, so 2x times 2x is 4x squared. I'm going to worry about changing the sign in a second. And 2x times -1 is -2x. All right, so then what we're going to do is we subtract here. All right? So that means 4x squared minus 4x squared, 0. Nothing comes down. That should always happen. And then -8x minus a minus 2x is -8x plus 2x, which is -6x. All right? And then bring down that 6. All right, so now 2x into -6x, in other words, you're doing this. So that just comes out to -3, right? So that goes up there, -3. And then we're going to multiply the -3 times the 2x minus 1, the divisor. So that's going to be -6x. Those should always match. Because when you subtract, they're going to be gone. And -3 times -1 is +3. All right, and as I said, we subtract here. And that changes the signs. So -6x plus 6x is 0. 6. Yeah, thank you. So it's -3 is going to be 3. That's our remainder. So then here's our, what they call the Q of x, the quotient. It's 2x minus 1. I'm sorry, 2x minus 3 plus 3 over the 2x minus 1. All right. And like I said, there's no sense in doing it, but believe me, if you were to take this now and multiply this by your divisor, you would get back to that thing up there.
If it was, if the 3 was negative, would it be in the denominator?
You mean 3?
I thought the other one was the whole number, the denominator was.
And the other problem?
Yeah, I thought it was underneath. Maybe I didn't do it right.
I don't think so.
Okay, no, never mind.
And the remainder goes over, because that's still division. That just means it's whatever's left over, still divided by that quotient. It means that just to simplify.
Yeah.
That's what it comes out to. All right. Now, as I had said, this stuff is almost kind of useless. It's just a bridge to show you, because it's really based upon this. And what we're going to look at is based upon this. All right, it's called synthetic division. It just works slightly different because we're going to do a couple of things so we don't have to worry about doing that subtraction. We're going to take care of that in one step. All right, so you still arrange the coefficients in a polynomial coefficient, not the coefficients. You arrange the polynomial so the powers are in descendant order. You got to have that. If there's anything missing, in other words, if it skips from cubed to x, then you got to put a 0 in to represent the x squared. Now, here's the thing that's a little bit different here. The divisor, we're going to see it as x minus c always. So just like with the circles, you remember how, or with the transformations left to right, how it was the opposite sign. So whatever this number here is, that's what you're going to divide by, unless it's positive. In that case, you're going to add a negative sign. because you got to compensate for that. So all we're going to use then is just that coefficient for that C there. And then we're going to divide in, and we're going to just multiply across, and then we're going to add. So watch this, how easy it works. So you add the values, and then you just repeat it until you got all your columns filled in. Anything that's left over is the remainder. So let's look at one, and I'll take you through one that I got. Okay. So it's not x minus 2. So we have to realize that we're dividing by let me show you there. X minus or minus 2, okay? If this were the long division, you would use x plus 2. And the reason why you're doing this is because you're actually working with the coefficient values and solutions. You're not working with the polynomial itself, all right? But it's based upon that. So what we're going to do is, if we were to set it up as long division, it would look like this. All right. And you can change it back to x plus 2, but I'm just saying this. That's why we're going to be using a negative 2 here as our C, and watch how the synthetic division works. All right. It's a lot simpler. So this right here is just a little square, and you put the negative 2 there. And then this is the coefficients of that polynomial, that function. See that was the 1x cubed 0x squared minus 7x minus 6. See, they put in placeholder for the x squared. Now, automatically, the first thing you do is just bring this thing down. Like I said, after that, it's really pretty easy, because you just take and multiply the negative 2 times the 1, get negative 2. And because we're dealing with, we've already changed the sign, we don't have to worry about adding that sign. We're just going to add it. So now add, and we get negative 2. Negative 2 times negative 2 is 4. Add, we got negative 3. Negative 2 times negative 3 is 6. We got 0. There's no remainder in this one. What this essentially means is, and we'll see it in a bit, this thing factors as this. And then we can factor that. We'll do that a little bit later. We'll factor that and find all the solutions. Yes, that thing's always, no matter what that is, that comes down first to get you started. It primes the pump, so to speak, and then you just multiply, put it there, add. Multiply, put it there, add. Multiply, put it there, and add. And they don't say this yet, but if that comes out to be no remainder, that means this is what we call a root. In other words, this is a 0. In other words, x equal to negative 2 is a solution. Or the factor x plus 2, and what's left over give you the original one. And like I said, we're going to see in a minute. Then you can factor this and find out what those roots are too. And like I said, that last section, and I think people were, listening a lot, because you got to find the y-intercept, and that one's usually pretty easy. And you found the x-intercepts, but we had to use equations or functions that were already factored for us, because you really don't know how to do that at this point. But we're going to be able to use this to find the zeros. And this thing is really pretty quick. And one drawback is sometimes you may have to do it a bunch of times to find one of the solutions. But believe me, it's quicker than anything else you'll ever find. So this thing is called the remainder theorem. The remainder theorem is simply if we do the division, the synthetic division for f of c, then that's going to tell us the functional value of f of c. So that's useful for anything, and it will be. So what does that mean? Look. Here we got a function, 3x cubed plus 4x squared minus 5x plus 3. There's no missing, none of them missing, so we just bring the coefficients to 3, to 4, -1, and 3. And then the -4 is going in there. So bring down the 3, 4 times 3 is -12, add -12 times -4 is 32, add 27. 4 times 27 negative is 108, bring it down is 105. So that tells us right there. And this is, like I said, it can be quicker in most cases than taking -4 and putting it in there and doing all that. You know how to find that, right? You would put the -4 in there and cube it, multiply it by 3, then put that -2, the -4 and square it, multiply it by 4, then multiply it by -5 and add the 3. This right here generally is quicker to do that. Find the functional value. Okay. So that's the second use for it. If there's no remainder, then it's a 0 or a solution. And then if we put any value in there and do it, then the remainder is going to be the functional value of that value of whatever we use for the quotient. The divisor, I'm sorry. What's that? Well, if I understand what you're saying or asking.
Where did the positive 32 come from? I see where the -12 came from.
-4 times -8. -4.
Oh, okay, gotcha. All right, got it.
Like I said, this thing is incredibly simple. And because we take care of that minus C thing first, then we don't have to worry about subtracting like we did with long division. And that was really the reason I went over a long division problem, to just show you how much easier it is to do with this. Oh, so what I was going to say is, I mean, we also do this. Let's see, it's 3x squared minus 8x plus 27 minus 105 over x plus 4. Is that what you're asking about? I mean, that's what we also know. So that's kind of what we were doing previously. If it's not a 0, then it's got a remainder. But that remainder theorem here just tells us that if we put a value in and divide it using the synthetic division, then whatever's left over, whatever that remainder is the functional value of what we divided with, of what our divisor was. All right, let's look at one on the board. I'm glad that the Zoom worked, because it hasn't been working the last couple of days from Canvas. So I had to go to the actual Zoom site. And then I got on here and I realized, well, I can't find it, but I was able to get into it. And for some reason, your course was actually on there, even though I still can't get to it from Zoom.
Are we allowed to use?
If you need to, sure.
Okay.
I'm glad you have the Zoom set up, because I really wasn't feeling well this morning.
Yeah, that's what I got it for. I mean, I was gonna plan on doing this even before the hurricane, because I mean, I've been doing Zoom classes for, almost 2 years.
I just wanted to.
So I'm still offering them. Just the problem
Does it
is,
work against, does attendance work against our grade at all?
what's that?
Does attendance work against our grade?
No,
Okay.
I mean, not, there may
Obviously,
be
you
a
have to-
correlation between attendance
Yeah,
and things, but the grade, I don't use it in calculations.
okay.
I'm gonna back and write in the. I mean, I'm planning to, if I ever not doing too well and I don't want to expose anybody or what, I'm gonna do it from my office. I just, well, I'm trying to give you a heads up so you don't necessarily have to come in here. So. All right, so I'm gonna add this is fifth, fourth, third. So, oops, oops. Okay. Right. Just kind of missing one. All right, so it's on x minus, so we're just going to take the 3. Like I said, it works just like it did with the circles, the vertex. It's x to the 5th plus 4x to the 4th minus 3x squared plus 2x plus 3. All right, so it's in that form where it's negative, so we just pull the 3. Remember, if it's a plus, just like with the vertex formula, and just like with the transformations from left to right, it's the opposite sign. And the reason being is it has to do with it being solutions. So we're working with solutions here. So 1, 4, here's the one that's missing, the 0, the x cubed term. All right, so that's it. As we bring down that 1, let's get Lance. Okay, look at that closely. 5th, 4th, what's missing? The 3rd. So you've got to have a placeholder if one's missing. Well, think about if you were like stepping along on that from 5 to 4 and you went to 2, it's not an even jump. So you've got to put an even hop in there so you're not jumping 2 spots.
The third power.
Yeah, the 3rd power. Exactly right. So we're bringing down that 1, and then we're going to do the same thing we've been doing. 3 times 1 is 3, and then we're adding up. 3 times 7 is 21, and then we're adding up, which is going to be 21. 3 times 21 is 63. Add up, that's just going to give us a plain old 60. 3 times 60 is 180. So that's 182. And then 3 times 182 is 546. So this is 549. That's the remainder. So as I had said is, then you can write this as, it's going to be 1 power less. So x to the 4th plus 7x cubed. And even though there wasn't a cube in the original, the dividend, what is it? The dividend, we have an x cubed in the quotient. That's why you got to have that space holder. Bill Ennis?
Why is it positive?
Let me put my test and then go back and move that. All right. You remember back when we had transformations? show you. So this was the thing that we talked about for transformations. There's some, it's okay. This one is a lot more complicated, it needs to be. But you know, anything that's added or subtracted to x, it's the opposite sign. So x minus h mean that we're going x. Well, I tell you what. Let me just grab one. Okay, so this is your basic function, the blue one. All right. So the red one, it was -3, but it causes a plus shift. For this one, the +3 causes the negative shift because it's the x, it's like this. You have to have the negative sign in there. So the shift is whatever this number is here with the negative sign there. So if it's x + 2, or in that case, x + 3, it's x minus a -3. So it's -3 shift. That's only for the x-axis, which is what we're working with here. We're working with x's. The y is different. Remember, that was just whatever it was hanging off the end. You either go up or down. So that's why. And what that does, that takes care of us having to subtract as well. We don't have to subtract when we make that row, we just add it, and it makes it a lot quicker. All right, so let's go back over here. So then that just tells us, oops, no, it was on the board. So that was the remainder right there, over x minus 3. See, there's a 3, it's right there. Because we gotta build a negative sign in there. All right, let's try one, define the f of x. All right, so let me doctor this up. So it was cubed and squared there. So all we're going to do is, in order to find that functional value, because that's what that theorem tells us there, the remainder that comes about from any values divided by any value c is going to be the functional value in that x value. So it's -2. So it's 4, 5, -6. And again, bring this down. -4, -2 times 4 is -8. Add up is -3. -2 times -3 is 6. Add up and that's 0. And then -2 times 0 is 0, so add up and it's -4. So that's what we want, and that simply means that f of -2 is equal to -4. So if you went through all that by plugging that -2 into here, cubing it, squaring it, and so forth, and then doing all this stuff, you'll come out with -4. It's a shortcut that this synthetic division can help us with.
So only on one like this, we don't change the sign. We just,
No, we changed the sign. Didn't
I'm
we?
talking about the -2. You just kept
Okay,
it.
but look. Let me show you what this means. If x is equal to -2, which is what this is saying, then that means the factor is x plus 2 is equal to 0. Okay? That's what that's telling us. Because if we go backwards and add 2 here, that's where that comes from. You're not having to change it because it's giving you the actual x value. It's saying x is equal to -2. So if we add 2 to both sides, then that's x plus 2 is equal to 0. So if you were actually dividing, this is the same thing as dividing x plus 2. It's not that we're departing from that. It's just that if they're telling you that define f of a negative value, that means this. It's the same thing as dividing by x plus 2. So yeah, you don't have to change that one because it's essentially already done for you.
Okay, thank you.
Mhm. Does that make sense? I mean, that's kind of what the idea of a zero function is. In other words, you can go back to this and look that if you have a -2 right here, plus 2, oh, you can't see that, can you? And the thing is, if I do the camera, I should have done it on here. I'll just go ahead and do it down here. X is equal to -2 means the same thing as by adding 2 to both sides, it means x plus 2 is equal to 0. So functionally, it's the same thing as dividing 4x cubed plus 5x squared minus 6x minus 4 by x plus 2. It's just that, yeah, they're handing it to you as a solution rather than as that factor. All right, let's see. That's almost pretty much it. But there's a couple more things. Well, what we can do is now put it to use. And as I said, in 2.3, when they wanted you to determine the behavior and try to graph the function, they had to kind of give you a little nudge, and they gave you some polynomials that were factored. You know, you had like x minus 2 squared or x plus 1/2 to the third. And then from that, you can tell the multiplicity, and you can also tell whether it either crossed or that it touched the x-axis. Well, the good thing about this is, like I said, is now we can use this to find out on any function what the zeros are. The problem being is sometimes you just have to guess and do them in order to figure it out, because if we didn't know what the root for this thing was, and we guessed -4, well, we would have been wrong because it didn't come out to 0. But we're going to see what I'm talking about now. So as we had said already, or we may have, I've said it, they didn't write it out. But if you got a polynomial, doesn't matter what kind of polynomial it is, if the c value is equal to 0, in other words, there's no remainder, then that x minus c is a factor just as I had kind of said about this here. All right,
So that wouldn't be a factor. then.
that's not a factor, no, that's right, because it came out to -4. But I was just showing you how that comes about. They might. Let's do the practice one, okay? Do that first.
I love the practice.
Yeah, I put it there.
I do it
Take,
like 3 or
take
4
the
times.
mysteries
It
out.
helps so much.
and I always get ticked off because I have somebody that say, oh, I flunked it, and then I go in there and they didn't take that. Because, I mean, I can't give you any more.
The practice test is almost like exactly the same.
Well, see, the thing is,
Almost. There's different equations, but the same setup.
yeah, and as I do that, and I don't know, some people don't like that, some teachers do, and they'll definitely crow about it, but I think that's fine to do that. All right, so we're gonna solve the equation, and they tell us that -1 is a 0 of f of x. In other words, that means that x is equal to -1. Or the same thing as a factor of x plus 1, it means the same thing. If x is equal to -1, then that's the same thing as there being a factor. So they're telling us that we've got a 0 here, or a solution of x is equal to -1. And given that, how can we find out what the other solutions are on this? Okay. So we're going to use the synthetic division. Remember, if x is equal to -1 is a solution, then that means that the factor is x plus 1. Factor is x plus 1. All right, so 15, 14, -3, -2, there was nothing missing in this one. Bring down to 15. 15 times 1 is -15. Add -1, -1 times -1 is 1. Add -2. And then -1 times -2 is 2. And look at that. They didn't lie to us. So x plus 1 is a factor, which is the same thing as saying that the one of the solutions is x is equal to -1. Which means that we can write this now as x plus 1 times that quotient of 15x squared minus x minus 2. Now, there's different ways to factor it. They don't really show you this. I'm sorry, there's different ways to solve a quadratic. Hopefully by now you know you can use the quadratic formula. Sometimes that's not the quickest, but you can also factor some of them. And then you'll also look at the thing that we looked at the very beginning, the completing the square method. Either one of those could be used. So we got one of the solutions. So what are those solutions? Well, we got to just go back, and that's essentially this is something that was covered in Math 09-7 here. So they don't really show you, but there's one. Let's see. Yeah, there's the first one. That was the one that was given to us. They factor it as this. 3x plus 1, which means x is equal to -1/3. And then 5x minus 2 is equal to 0, means x is equal to 2/5. And so there's a solution set. Now I'll go through one with you completely. But
I'm sorry, what?
work in there for solving that, because technically they're assuming you know that. And I'm going to go over another one and then didn't see it before. This is what when I do mine from my office, I have 2 computers so I can see what the students are seeing. I'm not sure on here. I just share screen. All right, so.
With someone joined.
Oh, okay. So let's look at one. And this will be the last thing in the section. All right, so solve If they haven't figured it out now, that means the same thing as zero. They use, this book uses zero, the term zero at the bottom. So that's cubed. And squared. So what we're going to do is we're just going to use the synthetic division and do what we've been doing the whole time. All right, so then that's 2. There's nothing missing here. Now 2. 2 times -2. -2 times 2 is -4. Add them up, that's -7. -2 times -7 is +14. So that's going to give us 3. -2 times 6 is 6. Negative. All right, so they didn't lie to us. X equal to -2 was a solution. So one of the factors is x minus 2. All right, that's the x is equal to 2. All right, now we're going to use this part to write what's left over.
Wouldn't it be x plus 2?
Oh, thank you. Yeah, you're right. I got it written on here. Just as talking and writing at the same time.
I understand.
All right, so that's what we know. All right, so we know that x plus 2 times this quadratic. And now, like I said, is we can solve that any way we want to. Let's just put it in the quadratic formula. It might be factorable, and sometimes factoring is quicker, but let's just put it in the quadratic formula. I'm assuming that, so remember, a is equal to 2, b is equal to -7. You gotta just watch out that the quadratic formula actually gives you the solution and not the factors, but we can fix that. Sorry, not 3, it's 0, it's 3. All right, so that's -7 plus or minus the square root of -7 squared. And as I remember, this one is factorable, but like I said, it isn't. And in case you don't remember, this is the quadratic formula. So just check and make sure I got it set up right. All right, I get the signs right. So it's 2x squared -7x plus 3 over 2a, which is 2 times 2. So that's 7 because it changes the sign. And then you got 49 minus 12.
8, huh? 4
Yeah.
times 2.
I'm sorry, 24. So let's see, 6 times 3, I'm sorry, 18, right?
No, because that's 4, right? And 2, that's 8.
8, and 8 times 3 is 24. Okay, I said 24, and then back down. There we go. This doesn't look right for me. Because I already factored this when I did it, and I know it's factorable, and that didn't look right. So 49 minus 24 should be a perfect square. $25, right?
Yeah.
So yeah, this one would have been factorable. All right, so that means there's the two solutions. X is equal to 7 minus 5 over 4. And the other one is 7 plus 5 over 4. All right, so that gives us 2/4, which is 1/2. 7 minus 5 is 2 over 4. So this is 1/2. And then this is 7 and 5 is 12. So that's 12 divided by 4 is 3. All right, so this thing would factor as x plus 2. We already got the solution, but I'm just showing you in case we need factors. 2x minus 1. So this is actually if you multiply both sides by 2 and then subtract the 1. This is why the only drawback of using the quadratic formula, if you don't get to see the factors, you got to recreate the factors. So that's the factorable form if they ask you. Because if you solve each one of these, you would get x is equal to -2, which we already knew about. X is equal to 1/2. And then x is equal to 3. So as I said, there's a drawback of using quadratic formula because if you were asked for the factors, you got to back up, multiply both sides by 2 and then subtract the 1 to get 0 and then take the here. It's changing the opposite sign. And that's kind of what you're doing when you're finding out that divisor is. This is the number you're going to be dividing by, but when you put it as a factor, it becomes on the other side and becomes negative. So see that with this method, we're able to find all of the solutions especially if we got one given to us. Now, this is the problem that sometimes it may not be given to us because we're actually working on something that's fresh. We're not going to know. So let me just kind of explain to you a little bit about the next section. We're not going to get through the whole thing. I just wanted to show you how it works because we're still going to be using synthetic division. So there's just kind of something that we have to do, and it's just going to help us determine what the solutions are. All right, you can read all this, but it just basically tells us that whatever the coefficient is of the first term and the coefficient is of the second term, we can kind of do this P over Q, reduce the lowest terms, and that'll tell us a possible factor. Let's just look at, because that to me is a pain. Gobbledygook, So let's just say we've got this function, 4x to the 5th plus 12x to the 4th minus x minus 3. Now, there's two terms. You got what's called the constant term, and then you got the leading term. All right, now, for the constant term, we're just going to look at all the factors of -3. Well, that would be plus or minus 1 and plus or minus 3. And why do you think that is? Because you can factor -3 as -1, 3 or -3, 1. So there's your combinations. But those are all the possible factors. That's why they've got plus or minus 1 in there. And that's why they got plus or minus 3. It really only results in 2 possibilities, but those are the 2 factors of the constant term. Now the 4 has got one more set because every one of them is going to have plus or minus 1. All right, but 4 also has 2 factors, so that means plus or minus 2 we throw in there, and plus or minus 4. Now, it looks kind of complicated, but that's why the synthetic division is nice and quick. So if you don't know which one, you can just pick one and go with it. It's either works. All right. So what we do is the factors is what they call the P. All right, the factors of the constant term, and the Q is the factors of the leading term. All right, so you can take all possible combinations of this. Well, that's 1 over 1, 1 over -1. So that accounts for that one. Same thing with 3. Then you go over to 3. Plus or minus 3 over 1 will give you those two. Then you can go on to this one. Well, 1 over 1 is still going to be 1. We already had that. And then 1 over 2 plus or minus. 1 over 4 plus or minus. Then 3 over 2 plus or minus. And 3 over 4 plus or minus. All right. Now, that's a lot of them to check. But believe me, that method is pretty quick. So we hopefully can figure some things out, because there's some, and we won't probably get into them today, but there are some things at the back of this section that will kind of assure you of knowing certain patterns that you can rely on. So here's another one. Find all the zeros of this. Again, the factors. The leading term is 1, and then the constant term is -2. So this one's got fewer because it's just got plus or minus 1 and plus or minus 2. And then there one, the only one we got is 1, plus or minus 1. So that's just 1 over 1 or 2 over 1, both plus or minus. So that's just 4 of them to check. Now use synthetic division to find out if one of those is a possible 0. Okay. So they wrote them all out there. That basically just means you got four of them, plus or minus 1, plus or minus 2. So 1, -1, 2, -2. So I don't know what order they picked. They picked -2 first. So put -2 in, bring down the 1, go through the process. It's not 0, so that's not a 0. So you can toss out -2 as one of the crossings of the x-axis, one of the zeros. -1, they're doing the -1 first, I guess. So bring it down, go through across. It's not a 0, it's 3. So we can rule out -1. Now there was 2 other ones, 1 and 2. So 1, let's see, was this okay. So those 2 aren't, but on this one, they do 1, not a 0, but they do this one, 2, plain old 2, it comes out to, and that tells us that there's a rational number root, which just means that it's a whole number. It could be over, I mean, even if it were 1/2, it should be rational, but I'm just saying this, as opposed to having a square root in it. So then x equal to 2 is a solution. Now, now that we found x equal to 2, we go ahead and divide by that. Well, that's the same thing that they just did, if you notice. They're just showing it again. Because that's now the quadratic you're going to solve. X squared plus 3x plus 1. So that's just what we did. So now we got to solve this one. They use the quadratic formula, and they must have known something here because this wouldn't have been factorable because it's got what we call an irrational root because it's going to have a square root in it. So then you go through and solve it, and there's your 2 other roots, -3 plus or minus the square root of 5 over 2. The drawback of factoring is you wouldn't have been able to find this one, and you would have to come back and do use this method to find it. Because the factoring doesn't allow you to find the roots unless you somehow have a savant head or something, because factoring generally, looking for whole number factors or whatever. So see, we found all the solutions because it was, by this starting out as a cube, remember, in the last section, we didn't know how to find those x-intercepts. All right, but now what we're going to do is we guessed one of them, kind of. It took us 4 tries to get it. So they're showing us that the last one, and they made it the last one to just show you how long it can possibly be, because chances are you're not always going to pick the last one and get it, It'll probably come soon. So then once you get that, then it gives you the quadratic, then you solve the quadratic, you got all 3 solutions. And now what you could do is, this would be easy then to go in and you have to take these and approximate them, and then you can find out the points on the x-axis where this thing crosses or touches. This was an x cubed. Oh, this one was a function of the original one. So this is the one where it would cross and then it would touch at those 2 points, because those are the squared function. All right, that's probably, well, let's just talk about this. Now, possibly, you may not remember it, but in 097, we go over these things called complex or imaginary roots. All numbers that we deal with are complex numbers, but it is possible for a complex number to have that second part, which is bi, and the I mean in the imaginary part. It's always going to have the I on it. So this is one thing that will just help you, that if you find one complex root or one imaginary root, then its conjugate is also a solution. They come in pairs when you're talking about these imaginary solutions. So in other words, if a plus bi is a root, then a minus bi is also going to be a root. So that helps you. And most of the rest of what we do revolves around just kind of things like this and helping us not have to do so much work. So let's just look at this real quick and then we'll call it a day. All right, so all possible roots, the 13 and 1 are the roots of the constant term, and then this one just got plus or minus 1. So then that just leaves us 1, -1, 13, and -13, just 4 of them to check. So going through here, the first one is a plus, the -1, because it is not 0. But the 1 is a solution, so x minus 1. Remember, we're going back to it being a factor when we put it here. Here it's x equal to 1. When we do there, it's x minus 1. And so what's left over is x cubed minus 5x squared plus 17x minus 13. Now we got to solve this one. Now that one's still a cubic, so we're going to have a little bit more work to do. So we still have the same roots because this one happens to be also be 1. So we're still checking the same ones in this case. So when you check them, we hit, and this time they hit right on the head. It was another 1. Okay. So that means this one has 2 x minus 1s. And what this essentially means is that's x minus 1 times x minus 1, or x minus 1 squared. So back to the 2.3, that means it kisses at that point, the graph. It doesn't cross because there's 2 of them at that point. So it touches and comes back down. All right, so then you have to solve this, and you can solve that using the quadratic formula. And this is where they tell us about that imaginary root thing. we go into all this and look, because it's imaginary, see, it's gonna have an I in it. The square root of, the negative sign of the square root means it comes out as an I. And then you take the square root of the 36, so it's 4 plus or minus 6i. So that means there's your two roots right there. That's your two main roots. When you see if you get both of them for the price of one. All right, well, we'll pick up there Thursday. We probably won't take the whole time, so bring any review questions you got. Like I said, in 1 week, we'll be in testing mode. Okay?
Is the test open?
I
I
have to
think you had
look.
emailed and said it was.
Huh?
I think you had said it was.
Well,
Not that I'm gonna
short
go see.
memory. All I can do is just check, because I do want to adjust them if they're not right.